Reassembling this will be easy, no question, but I still have some other things to look after. I will have to revisit the Model F keyboard, as I noticed there is some non-functional keys. Plus, I got myself another DIN cassette cable, and this time over, hopefully the correct one. And I organized these 40-year-old serial and PowerPoint cards. Will they still be working? Retrocomputing is the use of older computer hardware and software in modern times. I'm the vintage collector, and these are my stories. For the reassembly, I start by putting the power supply and the PC speaker back in. For the floppy disk drives, don't forget the notion from last time's video about the primary floppy drive requiring the active line termination. For the cabling to be nicely done, the primary floppy drive A must go into the left-hand drive slot. The secondary drive goes into the right-hand slot. The mainboard has those nylon retainers that I need to put back before I slide it back into the retainer rail. I'll have to secure the mainboard with 2 screws, although the one near to the power supply is a bit resistive. I had to use a clamping tool to insert it, as I couldn't probably hold it with my fingers. Upon inserting the floppy disk controller, I attached the floppy cable. Don't mix up the ports. The middle connector goes to the right-hand mounted secondary floppy drive, while the far end connector goes to the left-hand mounted primary floppy drive. This way the cables are neatly stowed and everything looks tidy. At the end I add the CGA adapter, so I can go further with another functional test. Now with the proper DIN cassette cable in place, I just load up the IBM Diagnostics from tape. This machine did not come with line interfaces equipped, so I have organized a serial RS-232 adapter board and a parallel port adapter. Usually, any such old hardware needs manual configuration using switches or jumpers. I checked out the IBM documentation once again, which pointed me at 3 configurative options. The top right shunt block is used to configure the serial adapter between primary and alternate mode, so to speak, whether is COM1 at memory address 3F8 and interrupt 4 or COM2 at address 2F8 and interrupt 3. Pay attention to the small circular hole on the top left, which indicates the primary orientation, so this card will become COM1. There is also a jumper in the center, which is only relevant if this card is to be installed into the 8th ISA expansion slot. In this case, the jumper must be close. But as I don't have any expansion chassis and the IBM PC mainboard has only 5 onboard ISA slots, I must remove this jumper. Note there is also a second shunt block at the bottom just beneath this jumper, which is used to switch the interface between voltage divider and current loop operation. For a pure RS-232 mode, you set it into voltage divider mode, which means the small circular hole must point to the upper left again. Interestingly enough, the parallel port interface card does not provide any shunt switches or jumpers, so it's hardwired to address 378 and interrupt 7. So this means that IBM foresaw the possibility to add a second serial adapter, but not a second parallel adapter. After all, adding these cards is straightforward. And after powering up the machine, I'm firing up the Diagnostics cassette once again, so I'm curious to see if the Diagnostics will detect these 2 new components. Oh, and how it does! See how they magically appeared. We've got a new entry for a parallel printer port, the async adapter, and for whatever reason, also matrix printer appeared. I have the Diagnostics run some tests on those 2 adapters. It'll yield codes 900 and 1100 respectively. This is totally okay as long as no explicit error message is shown. But maybe it's time now for a real test to see if these adapters really work. So while I could have used my ready-to-run floppy disks with LapLink already installed, I wanted to see it really from the beginning. So my idea was not only to use the serial remote installation capability, but also transfer LapLink over directly onto the second floppy drive. And while this seemed to work in the first place, it would eventually throw a program too big to fit in memory error message at me. So while I could transfer LapLink 5 over to the 5150, it essentially failed because it does not fit into the scarce random access memory. I went to try again using Laplink XL, which is less resource intense. While I could start the transfer, it would always result in a porting prematurely when copying to drive B. At first, I had suspected simply a bad floppy disk, but when trying to format the floppy disk, and later on with other floppy disks as well, I realized that the drive B seems to have a problem. While it seems to be able to read floppies written and formatted in other drives, it seems unable to either format a diskette by itself and furtherly perform clean writes to it. It troubles me that I need to review the second floppy drive now once again, after I had successfully tested it already a few days ago. Anyway, in the meantime I had managed to copy Laplink over via serial line transfer. Now I'm about to copy some files over from the remote computer. I just sneak off autoexec.bat for no particular reason, as all I want to see if it works for the transfer on COM1 using a 19,200 baud line rate. And it does. Now the same again using a 115,200 baud rate, and this one succeeds as well. And here's yet another one, this time over via parallel port transfer, and it works well. So I guess it's safe to say my serial and parallel interface cards seem to be functional at last. Lastly, I'm going to resolve the mystery around the CGA adapter and its RCA jack. After reading through documentation once again, I found that this is indeed a composite output. As I don't have any historic CRT TV around, I'm about to connect this Commodore 1702 CRT screen. IBM provided this for anyone to hook up the 5150 to an ordinary TV set, either by means of a standard composite input or, more likely, by use of an additional RF modulator to connect it to the antenna port. Not only was this convenient for those whom had already a TV at home to spare some expenses, but IBM had also good reasons to do so, as the CGA monitor 5153 was not available until later in 1983. It definitely doesn't look as crisp on the composite output as when compared to the 5153 display. This becomes more imminent when I run some graphic-oriented tests of the diagnostics cassette. At last my curiosity is settled, as now I could see this in action with my own eyes. And this concludes at least today's excursion into the 5150 reassembly. Unfortunately, I couldn't do everything that I had intended to. The still, or again, defective second floppy drive cost me, and I will need more time to investigate and repair this one. So as well, still pending is my second look at the IBM Model F keyboard and its stuck keys. And I must confess, during my testing, I suddenly ran into some short circuit situation that caused havoc onto my 5153 CGA display. In other words, it's dead, Jim. Well, nobody said it's gonna be easy, but look how far we have come, and the sky is just the limit. I hope you liked this video. If you did, then please give me a thumbs up. See you next time.